Okay, so guys, how do we solve this limits question? Okay, this is fairly simple and hear me out. This question, you have multiple ways to think about it. But from what we've learned previously and from the basics, if we have a limit of say x equals to a number, which is what we're most common with, say x equals 1, then you either have two options. One, you can sub this 1 into this bottom denominator and see if that equals to 0. If that does not equal to 0, so if it gives a whole number other than 0, then all fine, just sub x, just sub the value of 1 into everywhere where x is there, and the resulting answer is your limit. But if this does give you a 0, well, then you can factorize this to kind of eliminate this term, come up with a different expression, and then sub 1 in there and figure it out from there. But the problem here we have now, or with this problem, is that this is approaching infinity. And we want to really leverage this one idea that we know already, that infinity is a really, really big number. So something like 100,000 blah blah, and it keeps going. So take this 1 over infinity, right? Or suppose they say x is equal to infinity, 1 on x, which is 1 on infinity. So 1 on infinity, well, thinking about it, infinity is a big number, 1 on a very big number is a very small number. You might be intrigued. Wow, how is that? Just take the really big number, okay? 1 over this 100,000 we have here, right? Take this 100,000 and put it on the denominator, 100,000. And do you want to know what happens? What results you get? Well, when you type that into a calculator, you're going to get 0.00004 zeros and then a 1. That's what you're going to get. So I really want you to leverage that. 1 over infinity is a very small number. So 1 over a large number is a very small number. Okay? With that, we can go on and solve this question, because take this. I'll show you a shortcut and a long cut. First, I'll show you the traditional long method. Traditional. Oh, goody. So using the traditional method, in order to actually find this is what you're going to be doing. You're going to be wanting to divide through the entire expression by the highest multiple, by the highest degree. You see there's x squared here, right? You want to divide every single expression, so this by x squared, and in the end you will be able to get your limit by leveraging this concept. 1 over anything big is equal to 0. That's what we're going to be using in math. That's what mathematicians agree with. So let's do that. 6x squared over x squared minus 3x over x squared plus 4 over x squared, all thing over 2x squared over x squared minus 7x over x squared minus 1 over x squared. Okay, this is your function. We're using the traditional method here as mentioned. And look, for this function, right, these cancel out, then we're left with 6. These cancel out, 1x cancels out with one of the powers, and then here it's just 4 on x squared. Nothing's been able to cancel out. Same here with one of the powers. And then if you go on to rewrite it, you're gonna get 6 minus 3 on x plus 4 on x squared, whole thing over 2 plus 7 on x minus 1 on x squared. Okay, and this is as the limit of x approaching infinity. Now, this is the beauty. Take a look at this. At this point, right, we know that anything which has x on the denominator, where we're subbing in infinity, equals to 0. So In other words, this is equal to 0, that's equal to 0, that's equal to 0, that's equal to 0. Because anything over a large number, such as infinity, is an extremely small number of 0. So that just takes us down to 6 minus 0 plus 0, which is irrelevant, over 2 plus 0 minus 0, which is again gone, which is just 6 on 2, which is just 3. And that is the limit. That is the limit of this. It's 3. Now, that was all fun and games, but what is the shorter way we have of approaching this? What is the more kind of, test, exam way of approaching this question? Well, take a look at this. Because we know this factor, and because we know both the degrees are the same, what we can actually do in this case is just eradicate everything there and just take 6 on 2, and that will result you with 3. Just take the coefficients and divide through them. Because look back at this. What have we done? We have simplified it through, but then one like to realize all of these would have a denominator of x because you're simplifying it. And they're all going to end up as zeros. So essentially, you're just doing 6 on 2. 6 on 2. As mentioned, 6 on 2. So take the coefficients if they're the same degree and divide through them. Thank you.